Okay, so when you take the antiderivative, I felt like this kind of made my brain hurt a little bit, but if you know the derivative is 3x squared, and you know this is x squared, you know that the antiderivative, like what came before that, was obviously x to the third. And normally when you take the derivative of x to the third, you bring the 3 down and it'll become 3x squared. That's exactly what you want. And then remember, like you watched in the videos, you always want to put plus c at the end. Okay, so if f prime equals x to the 1, if we want to find the, oh, I should label this one, sorry. So I don't know if you guys heard in the video, but I kind of don't like how the notes already claim this top row is f of x. I changed it and claimed it that this is the derivative, and then here's the answer we're looking for is the antiderivative. So if you want to go through in your notes and label all the problems with the f prime to start, that's what I chose to do. Okay, so here we know that we would have an x squared, but think of what happens when you do x squared and you find the derivative. You would bring the 2 out in front. Well, we don't want a 2 out in front. So if we would take 2 times whatever's missing, you just put a 1/2 there. And again, don't forget to do the plus c. Here's the next 3 problems. So for number 3, if you think of what could you take the derivative of that's going to lead you to the cosine of x, and that would be sine of x. Remember, the derivative of sine is positive cosine, and then just don't forget to always put your plus constant at the end. Number 4, this made me think a little bit, but remember when you take the derivative of e to the x, it stays e to the x. So it's kind of the same thing works with the antiderivative. So kind of to get started, I wrote e to the 2x, and then I stopped and thought, what would happen if you take the derivative of e to the 2x? It stays e to the 2x, and then you would have to, let me change colors. So it stays e to the 2x, but then you'd have to do the chain rule and multiply by 2. And that's exactly what we want. So we know that this is the answer, but we wouldn't need to write our plus c at the end. Okay, number 5. So our antiderivative, if this is a 15x squared, I know that my antiderivative is x to the third. So if you think of bringing that 3 in front of the x when you take the derivative, 3x squared, well, we want it to be 15x squared, so that means there must be a 5 in front. Plus, this 4x term, well, we know it originally was an x squared. Well, what would need to be in front for us to take the derivative and get to 4x? A 2. And then for 3, it's just going to be a 3x, because you know the derivative of 3x is 3, and then remember to write the plus c at the end. Okay, for the next 3, so remember f of x equals, so what derivative leads you to 2x? Well, you know it started as an x squared, and the derivative of x squared is 2x, so that part's done. And then if you have a constant, it would just be 4x, because the derivative of 4x leads you back to 4, and then remember your plus c. For number 7, what derivative leads you to sine? Well, it's cosine, but remember the derivative of cosine's negative sine, so you would just make this negative to turn it back into positive sine, and then your plus c. And finally, number 8 is just kind of the opposite of number 7. If we know the derivative is negative sine, that is cosine. The derivative of cosine is negative sine. Alright, so for 9 through 12, number 9, the beginning is pretty easy because we know the derivative of e to the x does lead you back to e to the x. Think of what we would want this to be x squared. That 2 would come in front, but what could you multiply by 2 to get you up to 3? So 2 times 3/2. Does that make sense? So you can always check your answer by just taking the derivative of your answer. So e to the x goes back to 3 to the x. 3/2 x squared would take a derivative up to 3x. And then minus, we know that this was going to be x to the third, but we don't want to have a 3 in front. We just want it to be a 1. So if you take the derivative of 1/3, x to the third, you get back to x squared. And then remember your plus c at the end. Okay, 10 was probably the one I struggled with the most, but I did figure it out. So the f of x, we know this beginning starts out with an x squared, but if you would put a 2 in front of that, we just want a 1 in front of that. So we would put a 1/2, so 1/2 x squared. negative 1x would take the derivative back up to 1. And then this 4 sine of 2x. We know that the derivative of cosine is positive, or is negative sine. So we're going to do a negative cosine. And let me just show you why I'm going to put a 2 in front of this. I had to just kind of keep working this out to figure it out. So think of the chain rule. When you take the derivative of negative cosine, it will go back to sine of 2x, but then you do the chain rule and multiply by 2. But if we want to get back up to 4, you would need to have a 2 in front. I hope you can like re-listen to that and make sense of it. Basically, just take the derivative of this by hand to show it does lead back to where we wanted. Number 11 I skipped because anytime the derivative is 0, that means your f of x is just equal to c, and that's it. And finally, number 12, if the derivative is 1 over x, that's the same as writing it as x to the negative 1/2. So, so our original function, f of x, I don't mean to have that there. If we know the derivative is a negative half, that means the antiderivative was a positive half. And if, imagine taking the derivative of this red term, it'd become 1/2 x to negative 1/2. Well, I don't want a 1/2 there. So instead, what I do is I'm going to put a 2, because 1/2 times 2 would get us back to 1 x to the negative half, which is what we want, and plus c, of course.